let's move on to renewable energy in the battery space and electric vehicles, because that is something that Johnson Matthey is working on, is developing cathode materials for batteries, correct?
That is correct.
So just for context, one of the major issues currently surrounding lithium ion batteries is that overdependence on cobalt. And cobalt is fairly rare. It's toxic towards the environment, and it's often used as a trace element from the mining of other commercially valuable metals in these subpar mining conditions. There have been linkages to human rights violations. So due to these limitations, cobalt has the potential risk of dramatically hindering the mass adoption of lithium ion powered electric vehicles if the battery architecture doesn't change. So I wanted to ask you, how do you see these current limitations of existing lithium ion batteries limiting their mass adaptations into electric vehicles? And how do you see those challenges potentially being overcome in the next 10 years?
Yeah, I think that's a very good and very relevant question, of course, because, also here at Johnson Matthey, we want to do things in the right way. And I think that's really important. Something similar with cobalt. So also here it is very important if and when you use cobalt, and also cobalt as a specific applications that are really very worthwhile pursuing. But you need to make sure that your whole supply chain is a kind of certified by independent parties, and make sure that you know where the material comes from. That is where it's, for me, where it starts for us. That if you need it, there's no other way around it, that at least you use it, the materials that you know where it comes from, and then certified and what have you, as I said. What you will do immediately is, of course, think about, as a chemist, so can't I think about alternatives? Aren't batteries possible where you use very, very limited amount of cobalt or no cobalt at all? And now we take cobalt, but that is, of course, holding through in many of the chemistries. And that's, again, where material scientists play a role. Don't try to look at the LCA and at the footprints and traceability from the onset of a certain application and say, can I do a better job? And when you look at the cathode materials that we are developing at Johnson Matthey, they are very rich in nickel, and they use hardly any cobalt. And I think that is one of the trends. We have a material that is, first of all, it allows for very high energy densities. So you need less to propel a car, or you make the range longer, for example. But the other thing is that it also uses less and less cobalt when you look at the development over time. That also goes very, very rapidly. And it's a system that is also very versatile, which means that you can tailor it to the customer needs, and you can work with your customer to come to solutions where you use less and less, and in the end, maybe no cobalt whatsoever. So that is, of course, and should be a driver for those materials that are very, very rare. We need to take care that we only use them when absolutely necessary. I think nobody will debate that using minute amounts of platinum for anti-cancer drugs to save people's life, it's a very good application. But in other applications, if you can find alternatives or alternative approaches or shapes of a catalyst or what have you, to limit the amount of such materials, that's just a good thing. As I said before, it's about doing more with less.
I completely agree. We actually found an article that we shared on our LinkedIn page. It was #simple summary. Go check it out. But it was exactly the same things that you were talking about transitioning to nickel-based cathodes so that you can keep reducing. That was actually completely cobalt-free. And so it was just really cool to see how you can make that transition and solve so many of the issues that coincide with cobalt by transitioning to nickel.
Yeah, you can only do it when you employ great scientists. What we do at Johnson Matthey, and I hope that many of you who listen to this podcast think, hey, this is a very nice area. I need to go into the material sciences because I can then contribute to such transitions. And we have already covered quite a number during this podcast. Material scientists are at the core. So innovation never stops. There's always work to be done for good scientists, pushing the boundaries all the time.
And so On this realm of pushing boundaries and changing paradigms, particularly as engineers developing in our thought processes, there tends to be a larger emphasis on the cost of materials, the properties of the materials that we're working with, and the ease of manufacturing and making decisions. While unfortunately the role of sustainability in the decision-making process tends to be a little bit more limited, unfortunately, in our current state. But just as we discussed a number of ways in which these sustainable technologies make a significant impact on the earth. And it's relatively fascinating to see how innovations behind all those up and coming solutions, how can sustainability be rebranded in the workplace and in the classroom to make it so that it is one of those key down to the core motivators that engineers think about when they're making important business decisions or, research decisions or otherwise?
It is a very important topic, and I couldn't shout loud enough in this microphone to all these teachers at the university to make sustainability thinking and acting and all the principles of carbon footprints, scarce material, resources, etc., a part of the curriculum. And why do I say that? When you look at our customers, more and more they ask for all these kind of elements. It's part of the procurement decision they make. They have the choice between many different suppliers, and they will more and more make the choice not just for the cheapest, but for those that have a very good performance, attractive price, yes, but also sustainability is worth something. And also the fact that you certify where your raw materials come from and can show that. And that, impartial parties have certified it. All those elements are becoming more and more important. So for us as Johnson Matthey, that is great because we want to be this ethical company. And we believe in the end, companies who embrace circular thinking, sustainability, they will win in the end. It's becoming more, as I said before, a business imperative. And that means that our scientists, as I said before they start a project, they need to think and they need to write stuff down and checklist and what have you, have a dialogue with our sustainability department at the front end loading part of the project to think about all these different elements and then to pursue the right avenue towards a solution, something that solves the customer problem, but also that it is affordable and not only financially, but also from a planet point of view. And I think that is people, planet, profit. I think that is really important to take all those elements in the equation. Also, when you educate young people, we need this as an industry. So it should be obligatory in every year of every STEM curriculum, and ideally even much broader. Because there I mentioned before, many of the gigantic challenges that lie ahead of us, they are not just for chemists or physicists or metallurgists, the material sciences. We need economists that think that way, and legal people, and marketing, sales. We need them all. The challenges that lie ahead of us are so big that it's all hands on deck, and we can only solve it when we work very well together. And that's why it is really, really crucial that we start to educate the younger generation on all these principles around sustainability. Because we need you, your generation, to solve many of the issues, right? Because I have another, 10, 15 years to go. Many of the problems will not be solved by then. I hope we come a long way, will not be solved. Still a lot to be done. And that means we need to inspire the young generation to educate them to be these contributors in helping to solve the big issues.
Absolutely. You hit the nail on the head. And we realize that even today in our course curriculum, it's not obligatory for us to take a sustainability class with our engineering classes. And I think that needs to change. And it's honestly mind-boggling that that's the case. And I feel like even in high school, it should be taught too. Or a bit
absolutely
beyond.
And so simple to repair. It's so simple to repair. There's many experts out there, including industry, that would love to teach on those subjects because we all have the same drive. And that is, we need to make sure that we take a little bit more care of the planet and its resources, that it's also livable for more people and for many hundreds, if not thousands of years. and not decades. And I think that is, it's a moral obligation for the older generation to teach the young that there is a few things that we did not do right, and we need to correct it and educate them on ways how to approach these big issues and how they can help, how you can help solve these topics. Can be changed and should be changed tomorrow, also at your university. Yeah, very reputable university. So I'm sure in a few years they will be leading in this field if they want to.